Answers to Classwork week beginning 30th of March 2020. So question 1, volume of our cuboid. We're going to start by finding the area of the cross section. So this bit here. So that's going to be 3 times 4, which is 12 centimeters squared. And then we're going to multiply that by the length of our cuboid, which is 6 centimeters. So 12 centimeters squared times 6 leaves us with 72 centimeters cubed. That should have been. So that's the volume of your cuboid. Then we're going to have a look at question 2. So again, we're going to start by finding the area of your cross section, which is a triangle. So we've got base times height divided by 2. So 5 times 6 divided by 2. 5 times 6 is 30. Divided by 2 is 15 centimeters squared. And then that area of our cross section multiplied by the length of our prism, which is 20. So we've got 15 centimeters squared times 20 leaves us with 300 centimeters cubed. Question 3. Again, another triangular prism. So we're going to start by finding the area of the cross section first. Again, it's a triangle and it gives us the base and the height. So we know we've got base times height divided by 2. 7 times 5 is 35. Divided by 2 is 17.5 centimeters, or meters in this case, meters squared. And then we're going to do the area of our cross section times the length of our prism, which is 4 meters. So 17 meters squared times by the length of 4 gives us a volume of 70 meters cubed. Question 4. So this time our cross section is a parallelogram. Now, a parallelogram, to find the area of it, is the same as a rectangle. We're going to do length times the vertical height, or the width. So we've got 9 times 6, which is 54 centimeters squared. And then we're going to times the area of our cross section by the length of our prism, which is 12 centimeters. So times 12, and 54 times 12 leaves us with 648 centimeters cubed. Now, question 5. Before we did anything, we needed to make sure that all 3 of our lengths are in the same unit. So we've got 1.1 meters, 2 meters, but then we've got 40 centimeters. So we need to make sure, first of all, that we're converting those centimeters into meters. So to do that, we're going to divide our 40 by 100 because, of course, there's 40 and there's 100 centimeters in a meter. So 40 divided by 100 gives us 0.4 meters. So it's very important that we're working in the same units for each length. Now we're going to find the area of our cross section. So this front face here. So we've got 1.1 meters multiplied by 2 meters to leave us with 2.2 meters squared, because it's the area of our cross section. And then we're going to multiply that by the length of our prism, which we now know is 0.4 meters. So 2.2 meters squared times 0.4 meters leaves us with a volume of 0.88 meters cubed. Now, question 6. So our cross section this time is a trapezium. So the formula for the area of a trapezium is a half times a plus b times the height, where a and b are our two parallel sides. So 6 can be a and 10 we can call b. And the height is going to be how high our trapezium is. So 5 is going to be the height. And we can then substitute those values in. So we've got half times 6 plus 10 times by 5. So we can work out our bracket first. 6 plus 10 is 16. So we've got half times 16 times by 5. Half of 16 is 8. Multiplied by 5 is 40 centimeters squared. So that's the area of our cross section. Then we're going to times the area of our cross section by the length of our prism, which is 20 centimeters. So 40 centimeters squared times 20 centimeters leaves us with 800 centimeters cubed. Question 7. So our cross section is this T shape, which we're going to have to break up into rectangles. So I'm going to draw a little line across here to divide into our two rectangles. So we're going to start with our first rectangle here, this one on top. So we've got a length of 10 and a width of 3. So we're going to start by doing 10 times 3, which equals 30 centimeters squared. And then we're going to do our bottom rectangle. So this one here, which has a width of 4 and a length of 6. So we've got 6 times 4, which equals 24 centimeters squared. We're then going to add the area of those two rectangles together, and that's going to give us the area of our whole T shape. So we've got 30 centimeters squared plus 24 centimeters squared, leaving us with 54 centimeters squared. So that's the area of our cross section. Now we can multiply the area of our cross section by the length of our prism, which is 8 centimeters. So 54 times 8 is 432 centimeters cubed. Now, question 8. So the question asked you, how many of the smaller cuboids can you fit into this bigger box here? It's this bigger cuboid. So we're going to work out the volume of the smaller cuboid. We're going to work out the volume of the larger cuboid. And then we're going to divide the larger one by the smaller one to work out how many of the smaller ones we can fit into the big one. So we've got the area of our cross section, this front side here. So 6 times 9 is 54 centimeters squared. That's the area of the cross section, times by the length of our prism, which is 5. 54 centimeters squared times 5 is 270 centimeters cubed. So that is the volume of our smaller box here. So we can say 270 centimeters cubed. We're then going to find out the volume of the larger cuboid. So we'll treat this front bit here as the cross section. So a length of 30 and a width of 18 from up here. So 30 centimeters times 18 centimeters leaves us with an area of the cross section of 540 centimeters squared, which we're then going to times by the length, which is 50. So 540 centimeters squared times 50 centimeters leaves us with 27,000 centimeters cubed. Now to work out how many of the smaller cuboids fit into the bigger cuboid, we're going to do 27,000 centimeters cubed divided by 270 centimeters cubed. Which gives us 100. So that's how many smaller boxes we can fit inside the big container cuboid just there. Now for question 9. We need to work out the area of our prism here. We've got a cross section which is a parallelogram, which we know is the same as working out the area of a rectangle. So we've got 12 times 8, so 12 centimeters times 8 centimeters, which is 96 centimeters squared. We're then going to times that by the length of 20. So 96 centimeters squared times 20 centimeters gives us 1,920 centimeters cubed. So that's the volume of our prism. But what our question actually asked was, James wants to fill an empty flower pot with soil. He has 2 litres of soil. Given that 1 litre equals 1,000 centimeters cubed, does James have enough soil to fill the flower pot? Well, we were told he's got 2 litres, so if we convert the 1 to 2 litres, so we've multiplied that by 2, we're going to do the same to the volume, which will give us 2,000 centimeters cubed. So James has got 2,000 centimeters cubed of soil. We've worked out that his flower pot has a volume of 1,920. So yes, James does have enough. Finally, question 10. Again, we've got a triangular prism. Our cross section is the triangle here at the front. We've got a base of 9 and a vertical height of 4. So don't get tricked out by the slanted height of 6 centimeters. We don't need the 6. It's base times the vertical height. So 9 times 4 divided by 2 is 18 centimeters squared. So that's the area of the cross section. We're then going to multiply that by the length of our prism, which is 12. So 18 centimeters squared times by 12 is 216 centimeters cubed. We were told that this shape, our triangular prism, had been melted down to create a solid cube. What that tells us is that they both have the same volume. So this cube over here also has a volume of 216 centimeters cubed. And we know to find the volume of a cube, we do each dimension multiplied by each other. Now, because it's a cube, all sides are the same length. So it would have been x times x times x equals 216 centimeters cubed. Now, to simplify down x times x times x, we can rewrite that as x cubed equals 216. So again, we've got a little equation to solve. We need to work out what the cube root, because that's how we undo a cube root of 216 is. So we're going to cube root 216. So that's the little symbol on your calculator that looks like a square root, but it's got a little 3 just next to it there. So cube root both sides, and x equals 6 centimeters.